Hello student, in today's lecture we have to continue a chapter number 9 from the syllabus of physics, and it is optics. Last time we learned reflection, refraction, as well as laws of reflection, laws of refraction. In today's lecture we have to start the article refractive index. Now what is refractive index? So new article, refractive index. Basically, refractive index is represented by a symbol n. It may be represented by symbol mu also, mu or n. So let me use n for refractive index. Now what is refractive index of any medium? That we have to discuss here, because when we are learning the phenomena refraction of light, the refractive index is very important here. Now refractive index gives idea about a density of the medium. Last time we learned rare medium, denser medium. Denser means the more density medium. Rarer means a less density medium. Means here the simple conclusion is, if the medium having a more density, it means that it has a more refractive index. Less density means it has a less refractive index, that you note. Okay, now let me discuss here the two mediums, water and glass. You know that glass is a more denser, so glass having a more refractive index as compared to the water. Now what exactly mean by the refractive index? So that we have to discuss. You already learned refractive index in 10th standard also. But again we have to see what is refractive index. Basically everyone know that when light travel from one medium to another medium, it bend, and that bending is the refraction. As well as when light is enter from one medium to another medium, this velocity changes, wavelength changes. What happen about frequency? Note one thing, frequency is constant. Frequency is constant in all the medium. Okay, means frequency is not changing when light enter from one medium to another medium. Means wavelength changes, velocity changes. Now here, so based on that, change in the velocity of light in a medium, we define this refractive index. So refractive index of medium 2 with respect to medium 1 is equal to, we can write here, velocity of light in medium 1 divided by velocity of light in medium 2 is the refractive index. N is for refractive index. How to read this? Refractive index of medium 2 with respect to medium 1, and it is defined as a ratio of these two velocities. So I can use symbolically C1 divided by C2, or I can use V also for the velocity, but here for the velocity of light I use C here. So this formula we get, velocity of light in medium 1 divided by velocity of light in medium 2 is the refractive index of medium 2 with respect to medium 1. Now here the same formula, when light is entering from air to glass, we can write refractive index of glass with respect to air is velocity of light in air divided by velocity of light in glass. So this formula we can write for the refractive index of the glass with respect to air. Now similar manner, if you want to write refractive index of water with respect to air, then we can write velocity of light in air divided by velocity of light in water. Now how much is the velocity of light in air? Velocity of light in air is 3 into 10 raised to 8 meter per second. That is a constant and everyone know that. Take care. Then if it is 3 into 10 raised to 8, then we can find out how much is the velocity in the glass. You know that when light enter from rare medium to denser medium, then velocity of light decreases. Now how much decreases? It depends on the refractive index of that medium. Now here refractive index for glass is approximately, it is 1.5. If it is 1.5, then this is 3 into 10 raised to 8. You can find out velocity of light in glass is velocity in air divided by refractive index of glass with respect to air. So it is 3 into 10 raised to 8 divided by 1.5. So in glass, we can say that velocity of light is 2 into 10 raised to 8 meter per second. So this is the velocity of light in glass. It depends on the glass also, how much is the refractive index. So if the refractive index is 1.5, then velocity of light in glass is 2 into 10 raised to 8. Similar manner, you remember one thing here, velocity of light in water by this formula. You can transfer this to this side and this refractive index to that side. So Ca divided by refractive index of water with respect to air. Then velocity of light in air is 3 into 10 raised to 8. Refractive index of water is 4 by 3. 4 by 3. Or you can write 1.333. Recurring 3 is coming. Okay. So after solving this, whatever you get, or you can write here 4 by 3. So 3 is shifted up. So 3 into 3, 9 into 10 raised to 8 divided by 4. So this is the velocity of light in water. Or you can solve this. 4 2s are 8, 1. Again 4 2s are 8 and 2 is coming, 4 5s are 20. So into 10 raised to 8. So 2.25 into 10 raised to 8 is the velocity of light in glass. Now you remember some values of the refractive index for your reference only. So refractive index of glass 1.5, water 1.33. If we are talking about the diamond having a highest refractive index, and it is 2.4 approximately. Yeah, these are the approximate values. So these are not the exact that you remember. Now here we covered refractive index definition in terms of this velocity. Now here you remember, if we written the refractive index of any medium, means refractive index of glass with respect to vacuum, that refractive index is called as absolute refractive index. Now the next term is absolute refractive index. Absolute refractive index. Now absolute refractive index means refractive index with respect to vacuum or with respect to air is the absolute refractive index. You note one thing here. The refractive index we are taking for vacuum, it is 1. For air also it is closer to the 1.00 something we get. But it is closer to the 1. Refractive index for air or vacuum, it is closer to the 1. And refractive index of any medium with respect to vacuum or with respect to air, that we are calling as the absolute refractive index. Now here I written only with respect to air only, but we can write the refractive index with respect to another medium also. For example, refractive index of glass with respect to water, we can write as a velocity of light in this medium divided by this medium. So velocity of light in water divided by velocity of light in glass. So this is refractive index of glass with respect to water. And you know the velocity of light in this water and glass. You can use these values to find out refractive index of glass with respect to water. Now here, refractive index is a very important. You already learned in the 10th standard. So twinkling of the star. Why the star twinkle? The reason is the fluctuation of refractive index of the medium. So Earth's atmosphere, refractive index changes. Means refractive index changes means what happen exactly? The density changes. So and because of that, as we enter in a medium, the density is different in the different layer. If you divide the atmosphere in a different layer, the density is different in different layer. And because of that, the light having a different velocity in different atmospheric layer, and because of that, we feel that a star is twinkling. Means twinkling of the star is the example of fluctuation of refractive index of atmosphere. Okay. Now you note here, the refractive index is very important. Similar manner, just I told you, when light enter from one medium to another medium, velocity changes, wavelength changes, but the frequency is constant. Now we know one relation. We know So velocity of light is given by formula frequency into wavelength. Velocity of light is equal to frequency into wavelength. Now what is wavelength? Length of one wave is a wavelength. Okay? This wavelength term, frequency, velocity you already covered in the previous standard. So you already aware with this. You note one this relation. This relation you have to learn in the section 1 also. So velocity of light is equal to frequency into wavelength. Now I can write, hence, I can write this formula. Velocity of light in medium 1. Velocity of light in medium 1, I can write frequency into wavelength 1. I am not written here frequency 1 because frequency is constant. Similar manner, velocity of light in medium 2 is frequency into wavelength 2. So we get C1, we get C2. So these are the velocities. Hence, refractive index is, refractive index formula we can write, refractive index of medium 2 with respect to medium 1 is C1 by C2. Now let us substitute the value of C1 here as well as we substitute C2. Then what we get? So F lambda 1 divided by F lambda 2. Then here F is a common, get cancelled. So here we get formula. Refractive index of medium 2 with respect to medium 1 is wavelength in medium 1 divided by wavelength in medium 2. So we get a formula of the refractive index in term of wavelength also. This is second formula of the refractive index that you can remember. So if you given the wavelength in the two medium, you can find out the refractive index of the medium with respect to one another. I hope you understood this refractive index concept. As well as we can define refractive index in terms of more terms. For example, if I consider time is t, and in same time t, light covers a distance d1 in medium 1 and distance d2 in medium 2. Okay, let us erase this one. Okay, now here, in same time, if light covers distance d1 and d2 in medium 1 and 2 respectively, Okay, then we can write, you know the formula of velocity. Velocity in any medium is given, velocity basic formula, distance by time. So distance is d1, time is t. And velocity 2 I can write, distance 2 divided by time 2. And the time is same. So we get d1 by t and d2 by t. So if you substitute in this formula of refractive index, we get refractive index of medium 2 with respect to medium 1 is, so we can substitute here. So d1 by t, instead of this c1 I substitute this, and instead of this c2 I can substitute this. So d2 by t. So t get cancelled, we get formula d1 by d2. So this is also an expression for refractive index. So distance in medium 1 divided by distance traveled by light in medium 2 is also the refractive index if the time is same. So we can write a refractive index in terms of many more quantities, but you can remember these formulas for the problem point of view only. Take it. Then after that, after this refractive index, we have to cover a new article, and this article is total internal reflection. That total internal reflection again you covered in the 10th standard also. Okay. I hope everyone understood this refractive index article. Or one more formula I can tell you about the refractive index here. So in terms of real and apparent depth, pay attention. What is real depth, what is apparent depth? That I tell you. Now pay attention, if this is a beaker or glass, in that glass you have taken a coin. So this is a coin in a glass. ठीक है. So when the glass is empty, the distance of the coin from the upper edge is a real depth. Okay, it is real depth. Now when we let I draw the same diagram, same glass, when we filled it with water, then we observe that the coin is lifted by some distance. It is observed because of some refraction. It is observed because of refraction. Now the distance of this coin from the upper edge is called as apparent depth. So that distance is called as apparent depth. Okay. Now listen, why it is called as apparent? Actually, coin is not lifted. We feel that it is coming up. You can do this experiment at your home also. You can take coin in a glass and you can observe it. Then one more same size glass, you can take same 1 rupees or 2 rupees coin you can take, and you can pour some water in that and you can observe that. Then you feel that the coin in a glass with the water, you feel it is little above the another coin. So this is real depth and this is apparent depth. So here refractive index in term of real depth and apparent depth we can write. So refractive index of this water medium with respect to medium 1 is, we can write real depth divided by apparent depth. So this is also a formula for refractive index. Okay. I hope everyone understood what is refractive index. Now after the refractive index, we have to proceed for the next article. And that article is total internal reflection. Listen, side by side, you can note down the things which you want by pausing the video. These are the very important things. Next article is total internal reflection. Okay, we have to learn a new article, total internal reflection. Okay, reflection we learn, refraction we learn. Now this is total internal reflection that we have to cover. Now here, what is total internal reflection? We have to learn this article with respect to some points. First one is what is total internal reflection. The second point is conditions of total internal reflection. After that, applications of total internal reflection. Take it. Now first we learn what is total internal reflection. Now for this article, the basic is, you must have idea that when the light is traveling from rare to denser, where it bent? Rare to denser, it bent towards the normal. And ulta, denser to rare. If light is going from denser to rare, it bent away from the normal. And I hope everyone know this, because you already learned it in the 10th standard as well as in yesterday's lecture also we covered it. Okay. Now here in total internal reflection, we consider light is traveling from denser medium to rare medium. Now let I show here denser medium. So this is water, glass, anything you consider. Okay, this is source of light. Source of light. Now from this light source, a light is emitted. So one light ray incident here. So this is normal. So instead of going through this light ray in a straight way, it bent away from the normal. So just we discussed, when it is moving from denser to rarer, it bent away from the normal. So instead of going in straight way, it bent away from the normal. So some light ray get refracted, some may be reflected. Some means simply here we can say that partial reflection. Let I show some light here also. Some light is reflected, some light is refracted. Now we talk about only refracted light. So light ray bend away from the normal. This is the first light ray. Now I consider second light ray. So this is second light ray. This is second normal. Now if we consider this angle of incidence and this angle of incidence. So this is a larger. This angle of incidence is larger as compared to this. So here the angle of refraction is also a larger. So here it bend more away from the normal. Okay. Now next time I consider third light ray. So this is normal. Now, so here this angle of incidence is greater than this I2. So this angle of refraction is also greater than this. So it bent more away from the normal. And here we get this angle of refraction, we get 90 degree. So when we get angle of refraction 90 degree, that time the angle of incidence in this denser medium is called as critical angle. Is called as critical angle. Now, after that, I consider one more light ray. So this is light ray. It incident here again with an angle greater than this. So here I can write this angle is greater than this. Then this light ray, instead of refraction, here reflection is occurring. Instead of, see here. So as this angle is greater than this. So angle of refraction must be greater than this. So greater than 90. So the light ray is coming in the same medium. If light ray is coming in the same medium after bounce back from the boundary, then it means that it is not a refraction, it is a reflection. And this is called as total internal reflection. Light is totally reflected internally. And this phenomena is called as total internal reflection. Now in simple way, so this is denser medium. So this is medium 2. So this is basically denser medium. This is medium 1. So this is a rare medium. Okay. Now the second thing is condition. I hope everyone understood what is total internal reflection. I repeat it again in simple single sentence. When light ray is traveling from denser to rare medium, incident on the boundary of this rare medium with an angle greater than critical angle, then ray of light internally reflect in the same medium. This phenomena of light is called as total internal reflection. Now condition. Now what are the conditions? Conditions, in the condition we have to write when the total internal reflection happen. It happen only when the light is traveling from denser to rare. Can it happen when it travel rare to denser? No, it cannot. हमें कब दिखाई देगा टोटल इंटरनल रिफ्लेक्शन? जब लाइट ट्रैवल हो रही है डेंसर टू रेयर ओनली. तो पहली कंडीशन, लाइट रे must travel from denser to rare medium. Second condition for total internal reflection is this, about the angle of incidence. The angle of incidence in denser medium must be greater than the critical angle. The angle of incidence must be greater than the critical angle. Then only total internal reflection is occur. So this is a necessary conditions for the total internal reflection. Now let me cover some applications here. First application. So here you know that optical fiber. अभी ऑप्टिकल फाइबर सब लोग अभी ब्रॉडबैंड यूज कर रहे हैं नाउ बिकॉज ऑफ द कोविड सिचुएशन. जो भी इंटरनेट कनेक्शन बहुत लोगों ने लिया होगा, ब्रॉडबैंड, दे आर यूजिंग ऑप्टिकल फाइबर केबल. तो ऑप्टिकल फाइबर केबल में जो सिग्नल ट्रांसमिट होता है एक जगह से दूसरी जगह पे, दैट सिग्नल इज इन द फॉर्म ऑफ लाइट, एंड दैट ऑप्टिकल फाइबर इज based on total internal reflection. Now, what is optical fiber, how it works, that we have to learn in the next article. But here you remember, so this total internal reflection is used in the optical fiber. The second thing is brilliance of stone, brilliance of some stone. For example, brilliance of diamond. Diamond shine क्यों करता है? The reason is total internal reflection. अगर आप देखेंगे नेट पे सर्च करेंगे तो डायमंड कटिंग के बहुत सारे कोर्सेस है. हाउ टू डिजाइन अ डायमंड. अगर आप डायमंड बहुत ही केयरफुली देखेंगे तो डायमंड इज डिजाइन इन सच ए वे दैट इट हैज अ मेनी नंबर ऑफ सरफेसेस. अगर आप कोई डायमंड देखेंगे उसको मैग्नीफाई, छोटा है तो, अगर बड़ा है तो भी आप देखिए उसके सरफेसेस काउंट करेंगे तो बहुत सारे सरफेसेस होते हैं. सो व्हाई सो मेनी सरफेसेस? बिकॉज अगर किसी भी एक सरफेस से लाइट रे अंदर जा रहा है, then that light ray reflect internally 2-3 times and because of that diamond shine. तो डायमंड कटिंग के कोर्सेस है, अगर आप देखेंगे तो सर्च कर सकते हैं बाद में. सो ब्रिलियंस ऑफ द डायमंड इज बेस्ड ऑन टोटल इंटरनल रिफ्लेक्शन. ब्रिलियंस ऑफ डायमंड, ठीक है, उसमें हम टोटल इंटरनल रिफ्लेक्शन यूज करते हैं. देन ट्विंकलिंग ऑफ स्टार, ये एप्लीकेशन में नहीं हम बोल सकते, बट यह इन दैट ट्विंकलिंग ऑफ स्टार में भी मैंने अभी आपको बताया, सॉरी नॉट ट्विंकलिंग ऑफ स्टार, ट्विंकलिंग ऑफ स्टार तो फ्लक्चुएशन ऑफ रिफ्रैक्टिव इंडेक्स में आता है, सॉरी फॉर दैट. ना उसके बाद हम मिराज. नाउ नेक्स्ट वन इज मिराज. नाउ व्हाट इज मिराज? Mirage is an optical illusion of water. It is optical illusion of water in desert. It is optical illusion of water. In Marathi we called it as a mrugajal. Means feeling of water. So in desert we feel that at some distance water is there. But if it travels miles and means any distance, then also we cannot see means simply water. The reason is it is the illusion, optical illusion of water due to this total internal reflection. Now, how we get this mirage? So let I explain this one also in detail. So basically, you can observe the water on highways also in summer days. Generally in afternoon time when we are traveling in a car or any other vehicle, so at some distance we observe that road is wet, some wet patches we can observe. So it is also illusion of water. So that is also another application. Take it. So many applications of the total internal reflection we can write, but let I explain this mirage. So just in the beginning I told you refractive index means simply twinkling of the star is because of fluctuation of the refractive index. Similar manner, so here total internal reflection is also based on that fluctuation of refractive index. Means not the total internal reflection, this mirage is based on the total internal reflection. Now pay attention here, let I explain it here. So basically when I consider this is surface, I consider this is surface. Surface of earth. ठीक है. Now I consider this is sky. Now we have to divide atmosphere into different layers. We have to divide this Earth's atmosphere into different layers. I divide the atmosphere into different layers. See here. Okay. Now in afternoon time, generally when sunlight incident on the surface of Earth, it gets heated. अगर ये सरफेस हीट हो जाएगा तो सरफेस क्या करेगा? इसके नजदीक जो एयर है उसे हीट करेगा. जैसे ही एयर हीट हो जाएगी, एक एयर पार्टिकल है, एयर मॉलिक्यूल है, वो हीट हो जाएगा तो ऊपर चला जाएगा बिकॉज ऑफ कन्वेक्शन. यू ऑलरेडी लर्न कन्वेक्शन. ठीक है, तो यहां पे जो डेंसिटी होगी वो कम होगी. डेंसिटी एयर की कम होगी तो ये जो भी है रेयर मीडियम होगा एज कंपेयर टू दिस अबव मीडियम. ठीक है, ये पहला लेयर हीट हो गया, उसका जो भी एयर पार्टिकल है उसकी डेंसिटी कम हो गई. तो अगर ये सेकंड एंड ये फर्स्ट एंड सेकंड अगर कंसीडर करेंगे तो जो भी क्लोज टू सरफेस होगा वहां पे डेंसिटी कम हो गई, तो वो मीडियम आपको एज अ रेयर मीडियम एक्ट करेगा एज कंपेयर टू द अपर लेयर. अपर लेयर हैविंग अ मोर डेंसिटी एज कंपेयर टू दिस. तो ये रेयर हो गया, यहां पे मैं लिख देता हूं, ये रेयर मीडियम हो गया, ये क्या है, डेंसर हो गया. ठीक है, इन कंपैरिजन ऑफ दीज टू. उसके बाद क्या होगा, ये लेयर हीट होने के बाद यहां पे जो सेकंड लेयर है, लेट आई नेम दिस वन 1 2 3 4 5 6. सेकंड लेयर वाले एयर पार्टिकल हीट होंगे, वहां से फिर वहां की डेंसिटी कम होगी. देन अगर मैं थर्ड सेकंड मींस दिस थर्ड एंड सेकंड को कंपेयर करूंगा तो ये हो जाएगा रेयर मीडियम और ये हो जाएगा डेंसर मीडियम. इसका मतलब है with respect to upper layer, the lower layer is a rare medium. And you know that when light is traveling from denser to rare, it bend away from the normal. Now when the light ray is coming from sky, एक लाइट रे में कंसीडर कर रहा है जो स्काई से आ रहा है, इंसिडेंट हियर, तो ऊपर वाले लेयर के कंपैरिजन में नीचे वाला लेयर कैसे रेयर मीडियम है, तो इट बेंड अवे फ्रॉम द नॉर्मल. ठीक है, इंस्टेड ऑफ गोइंग इन स्ट्रेट लाइन इट बेंड अवे फ्रॉम द नॉर्मल. So here also instead of going in a straight line it bent away from the normal. जैसे सीधा जाना चाहिए था ऐसे, तो ये bend हुआ away from the normal. So again here also it bent away from the normal. ठीक है, तो यहां पे भी it bent more away from the normal. ठीक है, then एक particular layer पे ये internally reflect होता है. ठीक है, जैसे यहां पे it bent away from the normal, more away from the normal, more away from the normal. At one particular angle it bent, means it is internally reflected. When this angle is greater than critical angle, it is internally reflect. ठीक है, जब ये internally reflect होगा, अगर कोई आदमी यहां पे खड़ा है तो उसे ये लाइट रे उसकी आंखों में चली जाएंगी. Why we see the any object, हम ऑब्जेक्ट क्यों देखते हैं, क्योंकि उस ऑब्जेक्ट से जो लाइट रे आ रही है वो हमारे आंखों में गई तो हमें वो ऑब्जेक्ट दिखाई देता है. अगर वो हम अंधेरे में है, ऑब्जेक्ट उजाले में है, तो भी हम अंधेरे में तो भी उस ऑब्जेक्ट से जो लाइट रे आ रही है वो हमारे आंखों में गई तो हमें वो ऑब्जेक्ट दिखाई देता है. अभी यहां पे क्या हो रहा है, जो लाइट रे कमिंग फ्रॉम द स्काई इज इंटरनली रिफ्लेक्ट फ्रॉम द लेयर ऑफ द एटमॉस्फियर एंड रीच टू द ऑब्जर्वर्स आई. तो ऑब्जर्वर को क्या होगा, उसे ये जो स्काई है यहां पे दिखाई देगा.